All right, we'll get going. So let's talk about lines. Lines are pretty not terrible. There's two, maybe three ways of writing the equation of a line. Here's one way, y equal to mx plus b, which is known as the slope-intercept form. Why is it called that? Because you can easily see what the slope of the line is. Whatever the coefficient of x is, that's your slope. And what the y-intercept is. That's why we call it that. There's also what's called, we usually write it as a times x plus b times y equal to c. This is, in my opinion, the form you see less often, but it is called the standard form. And the thing that I think is nice about the standard form is it's sometimes easier to find both the intercepts. So in this form, although in the first form, it's usually really, really easy to find the y-intercept because like it's right there, whatever your b is your y-intercept. In the second version, it's usually pretty easy to find both x and y-intercepts. So they both have their uses. Standard form, I should point out, can be easier to find intercepts. I should also mention it's harder to see the slope. So in this format here, the slope is not immediately obvious. It is not whatever the coefficient of x is necessarily. So let's look at a couple of examples and let's use some colors here. I've got colors, might as well use them. Let's do this one in red, this one in green. Oh, maybe not green. Not green at all. Let's use blue. That pen is dead. Okay. So when I graph a line, you graph a line, I recommend doing a couple things. The first thing, come on in, is I really want, you should grab a handout, sorry. When you graph a line, I really think you should just plot 2 points and then draw the line through them. And the points I really, really would prefer that you find are the x and y intercepts. So to find the y-intercept, we're going to set x equal to 0. Right? Because if you're on the y-axis, you haven't moved left or right, which means x is neither positive nor negative. So you set x equal to 0 and then solve for y. Now, for both of these lines, that's really not too terrible. For the red line, let's do that one over here. If I set, it's always a challenge to find all the room I need, but fine. So down here, if I set in the red line, y equals 2x minus 4, if I set x equal to 0, I'm going to get y equal to negative 4. Easy peasy. For the blue line, which is y equal to negative 3/2 x plus 4, if I set x equal to 0, I get y equal to 4. It feels like a step I didn't even really need to do, but I did anyway. Oh, I should gotta make sure I don't bleed through the next page. All right, and then the same kind of idea works to find the x-intercept or intercepts. Lines don't have multiple x-intercepts, but other kinds of graphs can, like parabolas. So you only ever have one y-intercept, but you can have multiple x-intercepts for various graphs. Same idea. You're going to set y equal to 0 and then solve for x. So for the red line, if I set y equal to 0, I've got, let's see, 0 equal to 2x minus 4. I'm going to add 4 to the left. I'm going to divide both sides by 2. So there's my x-intercept. I guess there's my y-intercept too. And then for the blue line, it's a little more work. Let me do it up over here. If I set for y equal to negative 3/2 x plus 4, if I set y equal to 0, I've got y equal to negative 3/2 x plus 4. My usual default kind of mode of operation is to make things positive when I can. So instead of bringing like the negative 4 over to the left and then multiplying both sides by negative 2/3, I'm going to bring the x thing over to the left, plus 2. So I'm going to add 3/2 x to both sides and get 3/2 x equal to 4. And then what should I multiply both sides by? Exactly. You could also say you're going to divide both sides by 3/2, but that feels like more work than I want to do. I'm going to do the thing which is the same that looks different. I'm going to multiply both sides by 2/3. 3/2 times 2/3 cancels out. That's why we did that. You're left with x equal to 4 times 2/3. It might be easier to think about if you think of it as 4/1 times 2/3. 4/1 times 1. 4/1 times 2/3 is 4 times 2/1 times 3, which is going to be 8/3. Great. Now I have all my intercepts, and I'm just going to graph them. So let's draw the red ones first because they're a little easier to deal with. My red intercepts are a y-intercept of -4, an x-intercept of +2. And really at that point, you're just going to draw the line through them. You can find more points if you want to help you graph it better, but you really don't need to. You can also do like the over-up thing, where you know the slope here is 2. So we're going to go over 1, up 2, over 1, up 2, over 1, up 2. But really, when you're graphing a line, you only need 2 points. And the 2 points I really want to see are the intercepts. So why do more work? You don't need to. Except if you're a bad drawer like me. So we'll see here how this goes. Oh, I got a ruler. My little tiny ruler. Oops, it's at the drill in my hand. So there's my line. And something else I was going to say about that? No, I guess not. Oh yeah, you should draw little arrows at the ends to indicate that it keeps going on forever and ever and ever. The other line, so for this other line, if I want it to be super precise, I am going to find an extra point here because plotting 8/3 on my x-axis is not something I can do exactly. Like if it was 2, I know exactly what it is. 8/3 is maybe right about there. And then my y-intercept is 0,4, which is right there. I'm going to give myself one more point. I'm going to set, just to make it so it looks nice, I'm going to let x equal 2. Why am I picking 2? Because I know that if I plug in 2 here, -3/2 times 2 is going to give me a whole number. Come on in, Pre16?
Yeah.
Got a hand up. Have a seat. I'm talking about lines and parabolas.
Thank you.
You're welcome. So I picked 2 because I know 3/2 times 2 is going to be an integer. So when I plug in 2, I'm going to get y equal to -3/2 times 2 plus 4. -3/2 times 2 is -3. -3 plus 4 is +1. So I'm going to add another point there just to make sure that I get it right. Usually I wouldn't do that. Usually I wouldn't even draw these little marks, but I wanted to make it look nice for you all because, you know, try to make things look good. Here's my line. And yeah. So to graph a line, 3 things. 3 things? Sure, 3 things. Thing 1, find your y-intercept. Oops, let's not make it all smudgy games. Find your y-intercept. Step 2, find your x-intercept. Step 3, draw the line through those 2 points. That's it. That's how you draw a line. That's how I draw a line anyway. There are other ways of drawing lines. If you do it a different way, it is not wrong. But what I will say is when I ask you to draw a line, or usually when anyone asks you to draw a line, there is an expectation that you do give the x-intercept and the y-intercept. And at that point, you've already done all the work you need to do. So why bother finding more points? Again, you can. It's not allowed. Just you don't have to. All right. Also, if you'd ask questions, if you have questions. So I'm going to turn the page. If you have questions, don't hesitate to raise your hand and say words. Also, just want to make sure that people on Zoom can see what's going on. Good to go. Oops. Wanted to pin my face there. Okay. Hopefully the face will come up later, but if it doesn't, that's, I guess, not the end of the world. All right. So how do we find the equation of a line? Well, to find the equation of a line, you need 2 things. Find the equation of a line. We need 2 things. We need a point. Any point will do. The y-intercept would be best, but if we don't have it, that's fine. And we need the slope. So we've got a point already. We've actually got 2 points. You can pick either one. So point, check. To find the slope, we're going to use the slope equation. So if you have 2 points on your line, we can find the slope between them. So the slope equation, the slope between 2 points, is the difference in the y's divided by the difference in the x's. The order of subtraction does have to be the same, meaning if you're using the first, if this is x1, y1, and this is x2, y2, you have to do these ones minus these ones, or these ones minus these ones. You can't do, like you can't do 5 minus 1 over negative 3 minus 4. That's going to end up having the wrong slope. So also, just so you can think of it in another way, you can also think of this as the change in y over the change in x, or if you prefer, the rise over the run. All things we say about slope. So in this particular example, my slope is going to be, let's see, so I'm going to do 5 minus 1 over 4 minus negative 3. Keep things in order here. So I end up getting, let's see, 5 minus 1 is 4. 4 minus minus 3 is 4 plus 3, which is 7. There's my slope, 4 over 7. One way to think about that is for every 7 you go over, you go up 4. Or you can say for every 1 you go over, you go up 4 cents. It's kind of the same thing. And then I guess we need to find the equation of the line. So there's numerous ways of doing this. Yeah, I don't care which way you do it, but I do care that you do it right. So here are 2 ways of doing it. Way 1, you can use the y equals mx plus b form and plug in what you know. So I know the slope is 4/7. And then to solve for b, I'm going to pick either of the 2 points I already have. Doesn't matter which one. They're both going to be kind of gross. So let's pick 4, 5. So if I plug in 4, 5, that's 5 for y and 4 for x. So 4/7 times 4 plus b. All right, this is looking kind of gross. Let's see here. So I've got 5 equal to 4/7 times 4 is 16/7. And I have to subtract 16/7 over to the other side, so I should probably change 5 to a fraction with 7 as the denominator. So multiply that by 7 over 7 and get 35 over 7 minus 16 over 7 equal to b. And 35 minus 16 is 19. So I get 19/7 equals b. We're not done. Even though we found all the things we needed to find, we still have to write the equation of the line. So our line is y equal to 4/7 x plus 19/7. How much time have we got? And yeah, actually, that's probably the way I would recommend doing it. You can also use the point slope form if you prefer. We'll talk about that if we have time, but either way is totally fine. So you might have noticed I'm moving a little fast. That's because there's a lot to get through today. In the future, I will try not to move quite so quickly, but there's a lot of things to say. I'm trying to say them. 2 lines are parallel. What's true if 2 lines are parallel? Slopes are the same. Yes, slopes are the same. I'm running out of room. Here are 3 examples of lines that all have the same slope. Y equals 2x plus 5. Y equals 2x minus 19. And 6x minus 3y equals 8. All 3 of those lines have a slope of what? So then, 2, exactly. The first 2 are obvious, right? Definitely 2x plus 5, y equals 2, y equals 2x minus 19, that's equal to 2. The last one, to see what the slope is in that format, you would need to isolate y, which you could totally do. And if you did, you would definitely have -6 divided by -3, which would give you a +2 for the coefficient of x. So all of those have the same slope. They are all parallel. So lines are perpendicular. There's a couple ways to say this. You can say either their slopes are opposite or negative reciprocals, That's the board I'm not good at spelling. Reciprocals. You could also say it as their slopes multiply to -1. I should say, I guess, with one exception, which we'll see in a second here. So an example of this would be y equal to -3/2 x plus 1, and y equal to +2/3 x minus, it doesn't really matter, 5/7. Both of those lines, I should say, not both of those lines are perpendicular to each other. One has a slope of -3/2, and the other one has a slope that is the negative reciprocal of that, +2/3. You could also multiply those slopes together, and you would get -6/6, which is -1. So that's what I meant when I was saying the slope of -1. All right. A couple more things about lines. The equation y equal to c. I don't love c. C is not my favorite, but if you have y equal to c, you have a what kind of line? Like the horizon is horizontal. Yeah. So y equals c is a horizontal line. And a horizontal line has what kind of slope? Yeah. Which makes sense if you think about the rise over run thing, because if you're horizontal, you're getting no rise over as much run as you want. No rise over plenty of run. On the other hand, the equation x equal to c is a vertical line. And vertical lines are kind of a pain in the butt in that they have no slope, or I should say they have an undefined slope. Because you have a lot of rise over 0 run, and division by 0, problematic, right? We can't divide by 0. So you have plenty of rise over no run. That's a problem. It's a problem if you want there to be a slope. I should also mention, just because we're here, vertical lines are the only kind of line that isn't a function, because it fails the vertical line test pretty hard, right? If you draw the vertical line on the vertical line, it's touching all the points, which is the problem. So those are the ones that the only kind of line that isn't a function. All right, let's. Sorry, I've got papers everywhere. Also, for those of you on Zoom, feel free to, if you have a question, you're welcome to throw it in the chat, whatever. Papers. Okay. So there's always so much to say on this first day. So the lines, not too terrible. Find 2 points, usually the x and y intercept, draw the line between them. That's kind of all there is to lines. Let's talk a little bit about parabolas. And I'm definitely getting my, okay, there we go. So there are 2 different forms for the equation of parabola. I should say there's 2 different kind of typical forms. There are lots of other ways you could write it, but one way is to write it as y equal to a times x squared plus b times x plus c, where a, b, and c are real numbers. The only requirement is that a is not 0. If a were 0, you wouldn't have a parabola because you wouldn't have an x squared term. B or c could both be 0, that would totally be fine, but a can't be 0 because you have to have the x squared term to be a parabola. The other way we occasionally write the equation of parabola is a times x minus h squared plus k. So I should say, for this first term, this first way of writing it, this is called the standard form. Standard form, you know what? The names don't matter. It's probably called the general form. It doesn't really matter. This one is called the vertex form. And the reason it's called the vertex form is because we can see the vertex. And it's the point h comma k. So if you have a parabola written this way, the vertex is immediately obvious, or maybe not obvious, but is immediately findable. And we'll talk a little more about that when we get to an example. But let me say one other thing. For both of these, the A is the same. What I mean is that if you had an equation of a parabola and you wanted to change it from one form to the other form, whatever that value of A is would be the same in either way you wrote it. So if there was if A was 2 up here and you rewrote it this way, A would end up being 2 down here. And I think we will see that in a little bit here. Everyone's favorite parabola. Y equals x squared is my favorite parabola. Looks like this. I feel like it's a little hard to see. I kind of want to draw it in. See better. Kind of rounds out at the bottom. Whoops. My parabola drawing skills are, okay. We often think about plotting some points like 1, 1, and 2, 4, and 3, 9, and -1, 1, and -2, 4, and -3, 9. I don't really usually plot all those points. I kind of just draw the parabola, but we will talk about what we want to draw when we draw parabola. I should also, I guess, say the origin is also there. And I should say the vertex of this parabola is the origin. In general, the vertex of a parabola is either the lowest point if it opens upwards or the highest point if it opens downwards. It's also where if you cut the parabola in half along that point, you would have symmetry, right? It's the same on the left as it is on the right. It kind of like it's like kind of like a mirror image. Like these guys over here looking, those guys over there. They're like, oh, yeah, we look the same. So some notes about A. If that coefficient A is positive, the parabola opens upward. Parabola like a cup. I always think of that. Opens up like a cup. If that leading coefficient is negative, the parabola opens downward. Opens down like a sad. Not really. Parabolas can open down. And what if A equals 0? Well, it's not allowed, right? A can't be 0. It's not a parabola if A equals 0 because you don't have the squaring thing, which is making it. This is the whole parabola part of it. All right. So just like we mentioned, we talked about how I think. So I should just kind of quickly step over here for a second. You were getting math through the lens of my brain, right? Which is true in any math class you take, right? You're going to get it through the lens of whoever's teaching it. I am telling you the best ways I think to do things, hopefully the ways that are most efficient. If you have a different way of doing something that is correct, that is A-okay. I'm going to show you how I think the best way to graph a parabola is. But if you have a way that works for you, totally fine. That said, I do have some expectations as what I get when you graph a parabola. So let's graph x squared minus 2x minus 8 as best as possible. That is not my maybe best writing there, but whatever. So first and foremost, the vertex is the most important point of the parabola. So first, the vertex. So first, the vertex. Specifically, so the vertex has 2 coordinates. You get an x coordinate and a y coordinate, right? It's not just like one thing. There are 2 pieces to any point on the xy plane. I'm going to find the x coordinate first. And I usually like to label it as v sub x. It just works for me. And one way of finding the vertex of the parabola is by utilizing the tried and true formula, which we won't get into where it's coming from exactly yet. Negative b over 2a. When I say negative b over 2a, what do I mean? What's a in this parabola? And what's b? Negative 2. We do need to make sure we catch those negative signs, right? So a is just the coefficient of x squared, b is the coefficient of x, and c is the constant term. So in this one, a equals 1, b equals negative 2, and c equals negative 8. So in this particular case, the vertex x coordinate is negative 2 divided by 2 times 1, which is 2 over 2, which is 1. Cool. We still need to find the y coordinate. The way we find the y coordinate is by just plugging that x coordinate back into the parabola equation. So the y coordinate is going to be, I'm going to call it v sub y, and we're just going to plug in 1 into this equation. So it's going to be 1 squared minus 2 times 1 minus 8. That's going to be 1 minus 2, which is negative 1, minus 8, which is negative 9. So the vertex has coordinates v sub x comma v sub y. In this case, our vertex is the coordinate 1 comma negative 9. And I might as well plot it once I know it. So it's a little off the chart. I will also point out, I typically prefer to not graph on like a grid like this. I would just draw my coordinate. Like if I was really drawing this, like doing it on my homework, I'd be like, okay, there's my vertex. Not being super precise about where things are. I don't want to draw these little marks here. You can, totally fine, but I don't want to. The next thing I'm going to find, because I'm always going to have one, is a y-intercept. All right. Finding the y-intercept is the same process no matter what kind of thing you're graphing, whether it's a line, a parabola, a polynomial, some other kind of function, a trig function. The way you find the y-intercept is by setting x equal to 0. Because the y-intercept is always on the y-axis where you have not moved left or right, which means x has to be, I'm going to ask you a lot of times because like a thing people tend to forget in the future, but it's always the same. Even when your function is super complicated, finding the y-intercept is always just found by setting x equal to 0. So I set x equal to 0, it's usually pretty easy. If it's written like this, I'm going to get y equal to, I don't even want to write out 0 squared minus 2 times 0 minus 8, because really I just know it's going to be negative 8. So my y-intercept is going to be the point 0, negative 8. And then lastly, x-intercepts. Now, I should start this conversation by saying not every parabola has x-intercepts. If your parabola has a vertex that's above the x-axis and opens upwards, no x-intercepts. If your parabola has a vertex that's below the x-axis and opens downwards, no x-intercepts. This parabola, which way does it open? Upwards, because our leading coefficient is positive. You can also see graphically that it has to open upwards because my vertex is down there and the vertex is either the lowest or the highest point. Well, there's another point and it's above it. So the vertex has to be the lowest point, which means it has to open upwards. So I know there has to be x-intercepts. So I'm going to go ahead and find them. But if there weren't, I wouldn't bother. Right? I don't want you to spend time finding x-intercepts that aren't there. So if you can see, like, for example, if my vertex had been up here and my parabola opened upwards, I'd be like, well, I don't need to find any x-intercepts. I know there aren't any. Ow, ow. I hit my ring like the wrong way. That's terrible. My finger's like numb. That's terrible. Don't get old. I don't recommend it. Okay, so set y equal to 0, just like we did before, to find x-intercepts. So depending on the problem, sometimes it'll be nice and easy to solve this. A lot of the times they're going to factor. This one does factor. It factors as x minus 4 times x plus 2. And so then setting x minus 4 equal to 0, I get x equal to 4. Setting x plus 2 equal to 0, I get x equal to negative 2. My x-intercepts are positive 4, which I suppose I should write out as 4 comma 0 and negative 2 comma 0. So that's the third step in finding the parabola, is find the x-intercepts if there are any. Fun fact, the x-intercepts should be equidistant to the left and right of wherever your vertex is. So my vertex happens to be along the line x equals 1, and my x-intercepts are both 3 to the right and 3 to the left of that. So I'm good to go. I see the symmetry is working out the way it's expected to. And now the fun part, trying to draw it. It shouldn't be pointy at the bottom. Oh, come on. That's pretty good. It doesn't have to be perfect. It feels a lot more like it has to be perfect when you've got this kind of grid thing going on. I will also mention, because I think it's worth mentioning, this parabola, if you wanted to write it in the vertex form of this parabola looks like the following. It is, well, let's see, I know what the vertex is. It's 1, -9. So the vertex form is y equal to x minus 1 squared minus 9. You could totally multiply that out and see that it is the same. Right? That's going to be x squared minus 2x plus 1 minus 9, which is indeed x squared minus 2x minus 8. So when given a parabola in this form, this is the way I recommend graphing it. Finding the vertex this way, finding the y-intercept, finding the x-intercepts, and then graphing the thing. Yeah. Okay, let's do some more graphing. So, all right, my pages are all over the place. I got time. Oh, yeah, we got plenty of time. All right, cool. Cool, I can slow down a little bit. I feel like we're, again, if you have questions, welcome to ask them. Yeah, do I have, yeah. We'll get there. We'll come back to that idea. Let's look at two things. So y equals -x squared plus 6x and y equals 2x plus 3. What kind of things are these? Y equals -x squared plus 6x is a, or I should say, it's graph, right? It's a quadratic. It's a parabola, right? We kind of mean the same thing when we say result of it. I guess not exactly the same. And the second kind of graph is going to be a line for sure. All right, so find their points of intersection. How do we find where two graphs intersect? I know y'all are saying probably the right thing, and I totally can't what to say. What? Yeah. Totally, exactly. If you have y equals one thing and y equals another thing, if you're trying to find where they intersect, you can set those two things, the y's are equal to each other. So we're going to set -x squared plus 6x equal to 2x plus 3. And then we're going to find the x value or values, maybe plural, and then we're going to go back and find the corresponding y values because we need the coordinates x and y. Now, I would say your intuition is probably to bring everything to the left. That's usually what I would do. I'm going to subtract everything to the left. So I'm going to get -x squared, 6x minus 2x is 4x, and subtracting 3. And I am supremely not a fan of trying to factor the, whoops, I can't accidentally press those buttons. Of factoring when you have a -x squared. I really, really don't like it. And you don't have to do it. You certainly can, but my preference would be just to say maybe multiply both sides by -1. So multiply both sides by -1, I get +x squared minus 4x plus 3 equal to 0 times -1, still 0. And now that is much easier to factor, in my opinion. This factors as x minus 3 times x minus 1. So I end up getting x equal to 3 and x equal to 1. I will point out that you could factor this. Again, I'm so bad at it, factoring with a negative in front. I could try, it'd be -x and a +x. And then I think I need a -3 here and a +1 here. I think that works out. Yeah, that works out. I wouldn't do it that way. You still get the same answers, right? You still get x equal to 3 and x equal to 1, but it's just harder for me to do it that way. So if you have a negative x squared, you can multiply both sides by negative 1 and make it a positive x squared, which is way better. You make sure you multiply everything by negative 1, though, right? Not just the one piece we want. Okay, so we found the x coordinate of the points of the intersection. We need to find the corresponding y coordinates. And the thing that's neat is you can use either equation to find them, right? Because they should be where the lines intersect. So both of them should have the same y coordinate after these x coordinates. So I'm going to plug in x equal to 1 into either equation. If I do it to the line equation, I'm going to get y equal to 2 times 1 plus 3, which is 5. I get 1 comma 5. That feels wrong. No, that's right. If I plug into the other one, it'd be the same thing. Oh, actually, we should explore that. Just to check, if I plug into the other one, I get negative 1 squared plus 6 times 1. Okay. What should this equal? Right, should be 5, right? What's negative 1 squared? Well, so we have to look at what's written, not at the word that's not listen to the word that said, because I said it maybe in a tricky way. So is it negative 1 squared or is it negative 1 squared? Right, there's a difference there. And here, since there aren't any parentheses, we have to be doing the exponent before we do the minusing or the subtracting. So it's really 1 squared first, which is 1, and then the negative of that. So this is negative 1 plus 6, which is 5. I just want to point out, negative number squared without any parentheses is negative 9, whereas negative 3 quantity squared is positive 9. So be careful with that because it can be a little dangerous on occasion. And then for the other one, we had x equal to 3. So I plug in x equal to 3, I'm going to get y equal to 2 times 3 plus 3, which is 6 plus 3, which is 9. Or I could have used the other equation. I would have gotten x equal to 3, y would be, well, it's a 3, James. Negative 3 squared plus 6 times 3. Again, negative 3 squared. I'm doing the squaring first and getting 9, and then it's negative 9. That's negative 9 plus 18, which is 9. So either way you slice it, you get 3 comma 9. You don't have to do it both ways when you're finding the y coordinate. I just wanted to show you that you really do get the same thing. But if you use one equation to find it, you're good to go. And now I want to sketch both graphs on the same axis below. All right. I have to find all the things about the graph. So let's do the y equals 2x plus 3 graph first. For y equals 2x plus 3, the y-intercept, I'm going to set x equals 0. I'm going to get y equals 3. Let's do that one in red, even though I didn't write it in red. And then find the x-intercept. We're going to set y equal to 0. We're going to get 0 equal to 2x plus 3. So negative 3 is equal to 2x. So negative 3 halves is equal to x. I'm going to have the point halfway between negative 1 and negative 2. And we also know it should go through the points 1, 5, and 3, 9, which I suppose I could have started with. I didn't want to. So there's my red line. I've never used a ruler for draw things in class. I'm missing out. Clearly, rulers are great. Oh, look very straight on there. All right, the parabola is gonna be a little more work. So first and foremost, well, maybe second, but I'm going to say first and foremost. Which way does this parabola open? Upwards or downward? Definitely downward. Okay. So let's find the vertex. The x coordinate of the vertex. Let's see. A is negative 1. B is positive 6. And C is 0. There is no constant term. This is totally okay. So my x coordinate of my vertex is negative b over 2a, which is negative 6 over 2 times negative 1, which is positive 3. And we already know the coordinate you get when you plug in positive 3, because that's one of the points of intersection. But we could still do it. By would be negative 3 squared plus 6 times 3, which we already did up here, and we got positive 9. That's my vertex. That's the very tippy top of my parabola. And then my y-intercept is going to be 0, right? So find the y-intercept. If I set x equal to 0, I get 0 plus 0, which is going to be 0. Which is also one of my x-intercepts, right? It's on the x-axis as well as the y-axis. Finally, to find the x-intercepts, we're going to set y equal to 0. So 0 is going to equal negative x squared plus 6x. I said I don't like factoring when there's a negative x squared. This is one maybe situation where it's totally fine because I don't have to do the hard factoring. What can I factor out from each of those two terms? An x, or even I could pick a negative x if I wanted to. Either way is fine. If I did x, I'd have 0 equal to x times negative x plus 6. Or I could factor out a negative x and get a positive x minus 6. Either way, I'm getting x equal to 0 and x equal to positive 6. Those are my intercepts. So I already had 0 and then 6. Again, this is correlating with what we said before about the fact that the x-intercept should be equally spaced to the left and right of your vertical, of your vertex. Right? The vertex is along the line x equals 3. And if you go 3 to the right, you get 6. If you go 3 to the left, you get 0. So things are looking good. Zoom in a little. Zoom close up. All right, and then we try to graph the parabola. Let's see. So it's going to be from here to there. And I got to hit that point because I know they intersect there. Well, no, sorry, that point because I know they intersect there. Sorry about that. Looking all right. Cool. So there is your parabola. And then I think we're asked to shade the area between the two graphs, which is not very much. But the area between the two graphs is this little part right here. Shaded in. Yeah, got it. 6. So lines, parabolas, not too terrible. Yeah, cool. Still got time. All right, let's move on to the last page with extra problems on it. Extra problems. I think I'm going to skip to the second problem first, just because I want to talk about the method of completing the square. So completing the square is not a method we typically use to write a parabola, because sometimes it's just gross. Sometimes, like especially if the coefficient of x is not even, or if you have an a value that's not 1, things get messy real quick. But if you have a nice situation like this where a is 1 and b is even, then completing the square can look nice. So here's how we complete the square. Take your equation. And I'll write on the -5 and just, oh, someone else did this a different way one time. It was super cool. That's not the way I do it. I don't remember how it works exactly. So to complete the square, you take the coefficient of x, which is what? Oh, sorry, the coefficient not of x squared of x. -4. Take that -4 and we're going to divide it by 2. And then we're going to square it. So let's see, -4 divided by 2 is -2, and -2 squared is +4, right? It is a negative number and then squared after the negative, so it's a +4. And we're going to add that on. And then we're going to also subtract it off. Because you can't just add something on without subtracting it off. And then we still have the -5 over here. This is the same, right? I haven't really changed it. I mean, I know it looks a little bit different, but it's technically the same thing I had before. I just added a 4 and subtracted the 4, but really I haven't done anything to make it different. But now here's what we're going to do. We're going to group this part off on its own. So we've got y equal to x squared minus 4x plus 4. And then -4 minus 5 is -9. Okay. Here's why, or here's what completing the square allows us to do. This part in parentheses here, we can factor this. How does that factor? Well, let's say I'm looking for things that multiply to +4 and add up to -4. That's going to be -2 and minus 2. But really, I should write that as x minus 2 squared. Hence the name. So this is why this process is called completing the square. Because if you do it, you end up getting something squared. And now this is in the vertex form. If I look at this, we can see that the vertex has an x coordinate of, show me on your fingers. I also too wish for peace, but yes, it is 2. And a y coordinate, you have enough fingers if I say it's negative. Anybody want to show me both hands? It's this many, -9. So how do we see that from here? Well, we got time. Let me ask you all a question. Which way does this parabola open? Upwards or downwards? Definitely opens upwards. Okay, so the vertex should be the lowest point. So if I am writing my parabola in this form, well, when you square something, right, if the squaring is the last thing you're doing, there isn't like a negative sign afterwards. If you square something, it's always going to be positive, or I guess it could be 0, right? I guess you would say it's always going to be non-negative. So if I'm trying to find the vertex, which should be the lowest point, I want to make the y value as small as possible. Okay, so if I want to make this thing as small as possible, and this thing here, x minus 2 squared, is non-negative, what's the smallest this part can be? If I get x minus 2 squared, if I cover that up, what's the smallest that could ever be? Could it be -3? Could it be 1? What do I have to pick for x to get 1 right there? 3 or negative or 1. 1 would also work, right? But 3 minus 2 squared is 1 and 1 squared is 1. So I can make it as small as 1. Can I make it smaller? I think I could. What could I pick for x that would make it even smaller? If I pick 2, what's 2 minus 2? 0. And 0 squared is still 0. And that's the smallest that's ever going to be. Oh, that's the x coordinate of the vertex, right? The value that makes that thing the smallest it could be since it's opening upwards. So the reason that this version of writing a parabola tells you what the vertex is so easily is because you just say, oh, what do I need to pick for x that's going to make that square thing 0 to make it as small as possible? Oh, well, I have to pick x equal to 2. And if that's 0, I should say x is 2, which makes this part 0. What are we left with? -9. That's your y coordinate. So now the less nice thing about the vertex form is it's harder to see the y-intercept. The y-intercept is not -9. We could go back to the original form and see that the y-intercept is -5 by plugging in 0. Or if you plug in 0 here, oh, it is 1050, but let me finish this problem. So if I set x equal to 0, then y is going to be 0 minus 2 squared minus 9, 4 minus 9, which is -5. And then to find the x-intercepts, I set y equal to 0. Check this out. 0 equal to x minus 2 squared minus 9. Instead of trying to factor this thing, which you could totally factor, you can add 9 over here. 9 equals x minus 2 squared. You can square root both sides. So x minus 2 equals plus or minus 3. And then x equals 2 plus or minus 3, which is 2 plus 3 or 2 minus 3. So my x-intercepts are 5 and -1. My y-intercept is -5. There's my parabola. All right, and you're free to go. And then you have class. And then we'll do this line 1 next class. Or I'll probably write it up now and post it, but like, cool. All right. Have a lovely weekend. Homework is posted. You can start working on it. Homework A/B